Okay, here we have a real world problem. You drop a rubber ball from a height of 1 meter and it bounces back to lower and lower heights. So when you drop the ball, it'll bounce back, but it doesn't bounce all the way back to the height that you dropped it with, right? And then when it bounces a second time, it doesn't bounce even back higher. It keeps getting lower and lower, as demonstrated in this path that they've drawn here. So each curved path has 80% of the height of the previous path. So it's true. You can watch the ball bounce and it'll bounce, 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 right? It just bounces until it looks like it's rolling. So write a rule for the height of each successive path. So this first path is 1 meter high. And then this second height in our second path is going to be 80% of that. So 80% would be 1 times 0.8. 80% of 1. Of is multiplication. 80% is 0.8. So 1 times 0.8 would be 0.8 meters. And then you would take that 0.8 and you would multiply it by 0.8. That would be 0.64 meters. So that one's 0.64 meters. Then we would take that 0.64 meters and we'd multiply it by 0.8. And when we multiply it by 0.8, its height would be even shorter than 0.64. Go ahead and multiply that out. It would be 0.512. And then how would we find the next one? The next one is going to be 0.512 times 0.8. Do you see what the common ratio is here? What do you keep multiplying by? Well, you keep multiplying by 0.8. And that's how we're going to get 0.4096. So our height keeps decreasing, right? It's 80% of the previous path. So if we wanted to write an equation, A of n is equal to, well, what would we start with? We'd start with this initial height of 1 meter, and then we're going to multiply that by our common ratio, and our common ratio is 0.8. And then we're going to raise that to the n minus 1 power. So there's our rule. Now, what will the height be at the top of the fifth path? Well, we already have that value, but I'm going to use my formula just to show you how well it works. So A of 5 is equal to 1 times 0.8 to the 4th power. And when I put that in my calculator, 0.8 to the 4th power, I'm going to get 0.4096 meters high. And there we go. There's our answer. That's our fifth path. That's the fifth path. We already had it right there, but using the algebraic equation is really, really cool. A cool way to check to make sure that your answer makes sense, right? Sure. Okay, so what could we do this with? We could do this with a basketball. Basketball, same thing. Drop a basketball from a height of 2 meters. 2 meters distance determines our existence. 2 meters. 2 meters is approximately 6 feet. I wish we lived in a metric world. Metric is a pretty cool thing. So if you haven't learned how cool the metric system is, when you take a science class, hopefully you will learn how cool it is and wish that we were on the metric system. Each curved path doesn't have 80% of the height of the previous. This time it's 56%. So this ball is pretty flat, right? It's either flat or it's flat. Basketballs have a better bounce than that, but this one, pretty flat. Using the height in centimeters, write a rule for the sequence. So we go from meters to centimeters. Interesting. Interesting. Using the height in centimeters, write a rule. Well, how many centimeters are in a meter? There are 100 centimeters. Centimeters, 100. 100 centimeters in 1 meter. Therefore, 2 meters is equal to 200 centimeters. 200 centimeters. So that's what we're starting with. So A of 1 is equal to 200 centimeters. And R is equal to 0.56 because it's 56% of the height of the previous path. So I think that we are ready to write our rule. A of n is equal to 200 times 0.56 raised to the n minus 1 power. N minus 1 power. What height will the basketball reach at the top of the fourth path? So the top of the fourth path, that means n equals 4. A of 4 is equal to 200 times 0.56 raised to the 4 minus 1 power. And 4 minus 1 is 3. When we put that into our calculators, we should get 35.1 centimeters. And it says round to the nearest tenth of a centimeter, so that's what I did. That's a tenth. And nearest tenth of a centimeter, let's fix that, tenth. And tenth of a centimeter, yep, done. So 35.1 centimeters is our answer. Now I should have told you at the very beginning, let's go ahead and try this on your own. So I'll make sure that when I post this video, I make a little note at the top that says make sure you try this one before you just start watching the entire video, because I give the whole thing away here. I give the whole answer. It's gone. It's gone like a freight train. Okay, so that is our introduction to geometric sequences. I hope you've enjoyed this.